All right, everyone, thanks for logging in today. I'm going to give people just a few more moments to get logged in here, and then we'll get this presentation underway. All right, a few housekeeping instructions. In your window, you will see a series of buttons across the bottom of the screen. The chat button, which is the little message icon, opens a window on the right-hand side. Russ Bowman's here alongside me and will be here to answer those directly back as they come in. We will also review any questions that come in here at the end of the presentation. If you have any trouble with audio or video throughout the presentation, please let us know through this window and we'll see if we can help. In the event you lose connection or need to sign out of the webinar, there will be an on-demand version available shortly after the presentation. We will send out an email to all registrants that has a link to that video. If everyone could just give me a quick chat that you can hear and see everything here in the presentation, and we'll get started. All right, EXAIR is a manufacturer, direct seller, and global distributor of engineered point-of-use compressed air products. We are located in the northeast corner of Cincinnati, Ohio, where we were founded in 1983. All product designs focus on efficient and safe usage of compressed air. A little about myself. My name is Brian Farno. I am the Application Engineer Manager with EXAIR. I joined the team here in 2010. Before that, I worked in the CNC metal cutting machinery industry for 5 years as a service and product specialist/trainer. I graduated from the University of Cincinnati with a Bachelor's of Science in Mechanical Engineering Technology. I'm a motorcycle fanatic. I don't know a bike I've ever seen that I didn't want to at least try. And when I'm not here at EXAIR, I'm probably somewhere spending time with my beautiful and amazing daughters and wife. Brownie points for me. The goals for today's presentation are as follows. After this presentation, you will have an understanding of what static electricity is and how it is generated. You'll know how to determine if static electricity is actually the issue and methods to test for it, and several methods used in industry to eliminate static charge. To understand static electricity, we must first understand electricity. We may all know that electricity is a utility. It is used throughout industry and that it can be dangerous. But did you also know that it is a form of energy? Electricity is comprised of charged particles known as electrons and protons. When these particles move or are dynamic, they become a current, which is what you use when you plug into the wall at home. When they're stationary, they become a charge. So what makes up electrons and how do they play into this? To answer this, we will need to talk in terms of the molecular structure of materials in order to see where this comes from. All matter is made up of atoms, the fundamental structure of the universe. Each atom has a nucleus which is in the center. The nucleus contains protons and neutrons. The protons can carry a positive charge while the neutrons remain neutral. Surrounding the nucleus are rings of electrons which are negatively charged. The electrons are bound to the protons and neutrons through electromagnetic force. This binding force keeps the electrons inside of an electrostatic cloud with varying degrees of attractive force. The closer an electron is to the nucleus of an atom, the greater the attractive force. Thus, the closer an electron is to the nucleus of an atom, the greater the energy required to make such an electron escape. When these electrons escape, a charge is created. This charge is static electricity. This occurs most often on the surface of non-conductive materials, but can also occur on ungrounded conductive surfaces. A static, non-moving electric charge is created whenever two surfaces come into contact and separate, or when friction occurs between them. When two materials are in contact, electrons may move from one material to the other. That's shown in image A. Atoms with weakly bound electrons tend to lose them, while atoms with sparsely filled outer shells tend to gain them. This is known as the triboelectric effect. When the materials come in contact and then are separated or have friction between them, they retain this charge imbalance, which is shown in image B. Again, this charge imbalance is known as static electricity. Both positive and negative charges will remain static until contacted by or close proximity to a conductive or grounded surface. The static electricity sparks that are generated between surfaces or people is an example of such flow. Now that we know what static electricity is, let's look at what variables might affect the level of the charge. There are a variety of influencing factors. These include material composition, surface area, environmental conditions, and the state of the contact surfaces. The triboelectric series chart, shown below, shows the static buildup tendencies of various materials. As the separation between the materials becomes greater, the amount of charge becomes larger. As an example, the charge between glass and cotton will be smaller than the charge between glass and polyester. So what kind of interaction between materials can generate static? The answer is there are several ways to generate it. The first is the simplest. A static charge can generate from two objects simply touching. This is known as contact static buildup. A static charge is created from two objects coming in contact with each other and separating, often resulting in an instantaneous static charge. Electrons are transferred from the contacting surface on one object to the contacting surface on the other. The level of the charge depends on where the materials are according to the triboelectric series. A second form of static generation is when two surfaces are detached from each other. Detachment static buildup occurs when materials like adhesive tape and protective films are removed from the surface they are adhered to. Think of the screen protectors on those nice new smartphones. The principle behind this kind of static electricity is the same as contact static buildup. When the two surfaces are separated, not all the electrons stay with their original molecule. Any amount of static charge generated by this detachment is significantly larger than simple contact static buildup, due to the tight surface contact. The third method of static generation carries the largest charges. Friction buildup is created when two objects have friction between them. Again, the principle behind this type of static electricity is the same as contact buildup. There is just more force as well as larger surfaces contacting and separating multiple times. By adding more force and exponentially increasing the number of contacts and separations happening, the charge values are increased. Think of when a box is traveling down a non-conductive conveyor belt. It vibrates and rubs against the belt the entire time it's in contact. Then when it separates from the belt, it will detach the two mating surfaces, leaving a large charge on the box. What kind of issues can be caused by the static charges created by any of these methods? Well, with films, you might see it sticking to rollers, getting jammed, not laying on product correctly, or curling up. With labels, you might see them sticking to the applicator or sticking to the incorrect point on the product. They may curl on the edges and come off. They might not separate from their backing correctly. Filling stations or machines may see clogs in the drop chutes, materials bridging in the hoppers, inconsistent product flow, or spilling or dropping of the product. Products with coatings may see spider webbing or cracking. Trim or flashing may cling to the surfaces or may attract dust or debris. Sensors may become covered in dust or give false readings because of dust or static buildup. Scrap material may cling to areas of the machine, causing product changeover headaches. Static may also be causing annoying shocks to personnel when they need to interact with a product or process. This can be detrimental to morale and ultimately affect production. So how can we determine if static charge is the cause of the problem? Well, there's a tool for that. Many times a static charge will be located right where contact, detachment, or friction are occurring within the process. A simple diagnostic tool to determine if static is present is a static meter like the digital one shown here. This is a handheld instrument that is calibrated and will provide you the polarity and strength of the static charges present. Knowing these values can help determine how to prioritize your plan to eliminate static by neutralizing the areas with the highest charges first. It can also be used to measure the effectiveness of any static eliminating product or treatment which has been implemented by simply comparing the static values before and after the installation of the static eliminator. What are some methods to try and control the static charge generation? First, you can eliminate or minimize the source causing a static charge. This can be done by replacing non-conductive points of contact with conductive materials connected to an earth ground. Webs threaded around a series of rubber rollers will generate all three types of static generation: contact, frictional, and separation. Replacing them with grounded conductive rollers will reduce static buildup. Try to prevent parts from rubbing against each other or other non-conductive surfaces, replacing those static guide rails with conductive rails that are grounded. Or for pick-and-place stacking operations, pick up and lay down sheets rather than sliding them off of a stack to minimize the charge to a separation charge rather than a frictional level charge. If these equipment or process changes are not possible, perhaps changing the environment the process is in can help minimize the charge buildup. By increasing relative humidity in the area of static generation, the surfaces and materials in the environment can absorb the moisture in the air, or form a very thin surface layer of moisture which dissipates accumulated static charges. When relative humidity is low, static increases. This is why static increases in dry winter months and decreases in the humid summer months. This, however, is not always a viable solution. There are three methods to eliminate static charge that do not involve altering the production methods or trying to increase humidity in the area. The first we will discuss are known as passive static eliminators. They are a low-cost method to dissipate static charge through physical contact of the material with the eliminator. The most common passive eliminator is tinsel. It is generally constructed of a highly conductive copper wire that has to be connected to an earth ground and then placed in contact with the entire surface that needs to have the static charge eliminated. These require no power source, as it is simply dissipating the electrical charge to the earth ground. The disadvantages to passive elimination is that it must contact the entire surface. Some products cannot have copper coming into contact with the product, or the contact may cause a blemish which can result in a defect. The frayed nature of tinsel tends to collect debris and dirt in the area, and that sometimes falls onto the surface it is contacting. Due to the continuous contact, the tinsel will also wear down physically over time and require it to be adjusted or changed out. Rather than physically connecting the materials to ground using passive eliminators, there are non-contact eliminators known as active static eliminators. Active static eliminators are generally found in two types: radioisotope and electronically driven. Radioisotope static eliminators are used to eliminate static charges in certain environments where flammable fumes or vapors may be present. They do not have to come in contact with the material, and they use an alpha ionizer, which is a radioactive source called polonium. This blankets the areas surrounding the product with positive and negative ions. The isotope is generally wrapped in a metallic foil to protect the isotope as well as prevent exposure to personnel around the isotope. Because they have a regulated substance inside of them, they must be licensed according to state regulations. This generally means they must be leased and not purchased because they then have to be returned to the manufacturer after a given period of time. The isotope used, polonium-210, has a half-life of 138 days. These devices must be handled with care. If the metallic barrier becomes damaged, they must be contained and treated carefully due to the material being radioactive. The second type of active static eliminators we will showcase operate off electricity. EXAIR offers a full line of electronically driven Gen 4 static eliminators. These eliminators do not require contact with the surfaces being treated, which results in minimal maintenance required. They are effective at distance by blanketing the area with both positive and negative ions. They are designed to minimize the footprint needed, and they can also be coupled with an intelligent compressed air product to carry the static eliminating ions into hard-to-reach areas. There are products for small pinpoint elimination up to wide widths for webs or conveyors. All EXAIR static eliminators are shockless and safe for use near operators. When coupled with a compressed air device, the airstream is adjustable from a gentle breeze to a forceful blow-off. Now let's discuss the offering of static eliminators and their benefits. EXAIR's Gen 4 Super Ion air knives use the laminar airflow from the Super Air Knife to distribute ions faster, up to 20 feet away, and into somewhat inaccessible areas. Anywhere the ionized airstream touches will start to have the charges removed. They cover areas from 3 inches to 108 inches wide, with custom lengths available. They are exceptionally quiet, coming in at 69 decibels when operated at a forceful 80 psig inlet pressure. The knife itself, as well as the air lines needed to supply, are all small footprint and can fit into tight spaces within processes. If wide widths or laminar airflow is not a benefit for your process, we offer the EXAIR Gen 4 Ion Air Cannon. The cannon can effectively eliminate static up to 15 feet away while it is mounted on the included swivel stand. They utilize a small amount of compressed air, entrain a large volume of free ambient air, ionize the combined airstream to eliminate static at a rapid rate on any surface that the airstream reaches. They can be used one per application as shown here, or they can be mounted in an array to provide a halo of ionized air for charge elimination and debris removal. The Gen 4 Super Ion air wipes are ideal for piping, cable, extruded shapes that aren't always round, hose, wire, and many more items. They provide a uniform 360-degree ionized airstream in a 2-inch or 4-inch throat diameter to effectively eliminate the static charge on all surfaces of the product. The clamshell design allows easy installation on even continuous runs of product and allows for easy removal when needed. The Gen 4 Ion Air Jets are designed for stationary installations in processes or at workstations. They provide a concentrated airflow that can cover a precise spot without disturbing other areas. The quiet, focused airstream provides fast static decay rates and debris removal. The Ion Air Jet is the ideal way to remove static, dust, and debris from small parts prior to shrink wrapping, packaging, printing, painting, labeling, or finishing. They are also available on stay-set hoses with magnetic bases and foot-controlled valves to give a static eliminating blow-off station wherever operators need. The EXAIR Gen 4 Ion Air Gun is a handheld safety air gun that ionizes the airstream as it exits the barrel, giving rapid static decay rates with low compressed air consumption. It is the ideal way to remove static charge and debris or dust from three-dimensional parts, packaging, finishing, or assemblies. The Ion Air Gun includes a 10-foot long power cable to make it easy to reach around an operator's area. EXAIR Gen 4 ionizing bars are available from stock in standard lengths from 3 inches to 108 inches. Their low profile and easy mounting via an integrated flange make them ideal for tight fits inside of machinery and processes. There is no compressed air requirements for the bars. They can effectively eliminate static when used within 4 inches of any surface they are treating. EXAIR's Gen 4 ionizing point is a compact single-point ionizer that requires no compressed air to be effective up to 2 inches away from the point. The design allows for easy mounting over processes such as cutting, shown here, winding, or rewinding. It can also be duct mounted to ionize an existing airstream that is flowing over the surface that needs to be treated. EXAIR Gen 4 static eliminators do require a power supply to generate the ozone that eliminates the static charges. Gen 4 power supplies are available in 2 or 4 outlet options as shown. A selectable switch allows them to be operated on either 120 or 230 volts AC. The supply is protected from incoming voltage spike by a fuse that can be easily replaced if needed. The power supplies include a standard 3-prong US plug attached to an electromagnetically shielded modular power cable, as well as one that has pre-stripped leads for attachment to your own plug. The Gen 4 ionizers will connect through the stainless steel terminals to couple with the integrated ground reference. All EXAIR Gen 4 static eliminators have armored and electromagnetically shielded power cables to withstand industrial environments. These cables are also available in custom lengths with short lead times. The Gen 4 design incorporates an integrated ground reference to the power cables, resulting in no need for an external ground wire to be ran. Each product is UL and CUL recognized in addition to being CE and RoHS compliant. Products coupled with our engineered compressed air products also meet or exceed OSHA standards for noise level and dead end pressure directives. To recap this presentation, everyone should now understand what static electricity is and how it is generated, a method to determine if static electricity is the cause of an issue within your process, and know that there are 3 types of static eliminators used within industry: passive, radioisotope, and active. EXAIR offers a full line of Gen 4 static eliminators from stock that will service nearly any application you might have. We also have a 30-day unconditional guarantee on stock products for US and Canadian customers. This enables you to get a system in your facility and test it. Let's face it, the proof is in the results. Now I'd like to open the floor for some questions and answers. We'll go back through the questions that have come in here. First is, how is it beneficial to have both positive and negative ions to eliminate static charge? That's a great question. The charge on the surface needing to be treated carries a polarity with it. This polarity is decided by the triboelectric chart that we discussed earlier. Opposite charges attract and combine with each other to eliminate the charge. So flooding the areas with both positive and negative ions means no matter what polarity your surface charge is, it's going to get eliminated. Got another one coming in. It is, what if my material is on one end of the triboelectric series from the other? Another great question. So if your materials are at opposite ends from each other on the triboelectric chart, that's going to result in the largest charge possible. The closer the materials are, the better they will be at not losing electrons to each other. Go over one more here. What is considered a high static charge? Well, this is all dependent on the process at hand. Charges around a few hundred volts can be crippling to a printed circuit board manufacturer or other sensitive electronic manufacturer, while a paper converter or printer might have processes that hold up to a few thousand volts before they're affected. The level of the charge that affects your process is considered high to you, and that is what we are here to help with. In closing, EXAIR has a full team of subject matter experts that are available to help with your applications. Feel free to reach out to any engineer here with any questions you may have. Thanks for watching and have a great day.